In this video, I'm going to show you how to find the nth term of any quadratic sequence. And in theory, it is a grade 9 topic. But if you follow this method, I think any student can do it. So all we have to do is find an expression in the form an squared plus bn plus c, which represents this sequence. So if we plug in 1 to this expression right here, we should get 6. If we plug in 2, we should get 10. If we plug in 3, we should get 16, and etc. And the first step of this method is to find the difference in between each of the numbers. So between 6 and 10 is 4, between 10 and 16 is 6, and then 16 and 24 is 8. And now once we've done that, we need to find the difference in between the differences, which is just called the second difference. So in between 4 and 6 is 2, and between 6 and 8 is 2. And in a quadratic sequence, these two numbers here should be the same. Alright, so once we found the second difference, we can use that to find our value of a, which is just the number before the n squared in our expression. And this brings me on to our first equation we use, which is that 2a, so 2 times this number right here, equals the second difference. So in this case, 2. So then we can just divide by both sides by 2 to get that a equals 1. So that means our a value here, we can rub it out and replace it with 1. 1n squared, which is just the same as n squared, so we can just get rid of that 1 right there. And then once we found a, we can use our second equation to find b. And that's going to be that 3 times a plus b equals our first difference. So in other words, the difference between the first and second number. So in this case, 4. So we can say that 3a plus b equals 4. And luckily, we've already found out what a is. So we can just substitute that in. So we can say that 3 times 1 plus b equals 4. So 3 plus b equals 4. And then if you take away 3 from both sides, we just get that b equals 1. So again, we can substitute this b for a 1, and writing 1n is just the same as writing n, right? So there we have it. The first two terms are n squared plus n, but we're still missing the value of c. And now to find the value of c, we got yet another equation, the last one, I promise you, and that's just that a plus b plus c equals the first term of our sequence. So in this case, 6. So then we just substituted our values of a and b. So a was 1, b was also 1, and then c we don't yet know, equals 6. And then if we take away 2 from both sides, we'll get that c equals 4. So that means our c value will be 4, and that will be our sequence right there. So say we were to plug in 3 to this right here. I always like to do this at the end just to check I've got the value right. So let's just go down here, running out of room on the right whiteboard, but we'll go substitute in 3 for n, so 3 squared is 9, plus 3, plus 4, and this should equal the third value of our sequence, and yes, it is 16. If we look right here, 9 plus 3 plus 4 equals 16. So that's just kind of confirmation that our method was right, and we have in fact got the right expression. So that example I showed you first was the most common question type you get on quadratic sequences, but there is actually another question type you can get, which is find the term that has the value of whatever it is. So the way we solve this, so basically what we're trying to do is find the value of n that will give us 272 when we plug it into this expression here. And the way we do that is we'll say that 2n squared plus 4n minus 14 equals 272. Because this way we can solve this equation for n using our knowledge of how to solve quadratics, and then we'll get the two values of n, and hopefully one of them will be negative, because then we can discard that one since we don't have negative values of n, right? So let's rearrange this. So we get 2n squared plus 4n, and then we're going to take away 272 from both sides, giving us minus 286 equals 0. And I don't know about you, but this one looks pretty hard to factorize for me. It should be able to factorize since we are going to get integers for the value of n, but personally right here I just probably plug it into the quadratic formula. So we're going to say that n equals minus 4, because minus b, right, plus or minus the square root of 16 minus 4 times 2 times minus 286. And then we'll do all of that over 2 times a, so over 4. And to tell the truth, I have already plugged this into my calculator, and I know that the two values it gave were 11 and minus 13. And obviously we can discount minus 13 because n has to be positive. So our value of n is 11. And if we were to check this by plugging in 11 into this expression right here, hopefully it would give us our value of 272. Alright, so now you've seen this tutorial on how to find the nth term with these quadratic sequences, it's time for you to have a go. So for each of these, I want you to find the expression for the nth term, and then for this first one, I want you to find what the 10th term of this sequence would be. And then I want you to be careful with this one since it's going down, but the same equations apply. Still 2a equals the second difference, etc, etc. Don't be scared by the fact that it's going to go down, right? Okay, so let's start with this one. Here's how to find the nth term of this quadratic sequence. So the first thing we're going to do is, I'm just going to rub this little bit right here, is I'm going to find the difference in between each of the numbers. So we're going to go plus 1 right here, plus 2, and then plus 3. And then I want to find the difference between these differences, which is going to be 1 and 1. So then we can set up our first expression. And before I do that, I'm just going to write our expression for the nth term in the form an squared plus bn plus c. And then I'll work back and find each of these values and replace them in the equation, of course. So our first equation that we're going to use is that 2a equals the second difference, so 1. And that's going to be, so 2a equals 1. And then I just have to divide both sides by 2 to get that a equals a half. So just going to replace a right here with a half. And then next, our equation to find b, and that's 3a plus b equals our first difference, so the difference between our first and second term is 1. Then I'm going to replace a in this equation with the value we found earlier, so 3 times a half, so 3 over 2 plus b equals 1. And then we're going to get, if we take away 3 over 2 from both sides, we're going to get that b equals minus a half. So again, just going to replace the b with minus a half. And then all that's left to do now is find c. And so we can say that a plus b plus c equals the first term of our sequence minus 2, which you can see why it's going to be the first term of our sequence is going to be a plus b plus c, right? Because when we substitute n equals 1 into this equation, all we're going to be left with is the values of a, b and c, which is just a quick explanation of why that equation works. And to tell the truth, I don't really know why these ones work, they just do, so trust me. So we're going to have a half plus a half plus c equals minus 2. So then if we take away 2 halves from both sides, so take away 1 from both sides, we'll get that c equals minus 3. So we're going to get a half n squared minus a half n, and then change that plus to minus 3. And that's going to be our expression right there for the nth term. So now we're going to find the 10th term of this expression. And all we have to do is substitute 10 anywhere you see an n in this expression. So we're going to have a half times 10 squared minus a half times 10 minus 3. And then we can say a half times 100 is going to be 50, minus a half times 10 is going to be minus 5, and then minus 3, and then that's going to be equal to 42. So the 10th term, if we kept on going and going, would be 42. And then the last question of the video is going to be how to find the nth term of this quadratic sequence where we're going down in each term. So we're still going to use the same three formulas. 2a equals the second difference, 3a plus b equals the first difference, and a plus b plus c equals the first term. So let's first find the difference in between each of our numbers. So we're going to have minus 4. It's important you have that minus there because that's going to come important when we put it into the equations. Minus 6 and minus 8. So then we're going to see that the difference between these differences is going to be minus 2 and minus 2. So we can form our first equation and say that 2a equals minus 2. So then if we divide both sides by 2, we'll get that a equals minus 1. And of course, I'm talking about the expression an squared plus bn plus c right here. So once we found the values of a, b and c, we can just substitute them back into this expression to find the full expression, which is going to be our answer. So now we found a, we can say that 3a plus b equals the first difference, or in other words, the difference between the first two terms. So it's going to be equal to minus 4. So we're going to say that 3 times minus 1, which I'll just write as minus 3, plus b equals minus 4. So if I add 3 to both sides to find the value of b, we'll get that b equals minus 1. So then I can replace the a right here with minus 1 and replace the b with minus 1. And all we've got left again is just to find 0. And hopefully you should know by now that a plus b plus c equals the first term of our expression, so 19. And then if I substitute our values of minus 1 and minus 1 for a and b, so minus 1, add c equals 19. And then we just have to rearrange by adding 2 to both sides to get that c equals 21. So I'll put that into our expression right here. And kind of sorry for doing it in the middle of the board right here, but you can see right here, this is our expression. And again, we can just do a quick check. So say, let's just check on our second term here. So substitute in 2 for the n. So we're going to get minus 4 because, you know, minus 2 squared. And then minus 2 again and plus 21. And then this is going to give us 15. So that's just to check that our answer's right. But if you follow these equations correctly, you should always get that answer. So hopefully these questions shouldn't seem so daunting to you anymore. Just follow these 3 equations and you should get the answer every single time. And I suggest you keep practicing these on websites like Maths Genie or Corporate Maths, just to make sure you get enough practice using those 3 equations.